Welcome to part 4 of our lecture video series from Monday, March 20th, where we are going to familiarize ourselves with kind of the broader classes of chemical reactions that we might encounter out there in the world. And I have split these into kind of 5 main classes. So let's jump on in looking at what kind of form these chemical reactions might have. So the first is called a synthesis reaction. So syn, like synergy, synonym means together. Thesis, something that is crafted. So things coming together to craft or make something new is a synthesis reaction. And these always have the form of component A coming together with component B to form some new compound, AB. So we've seen this in the lab by looking at our reaction of solid magnesium with oxygen gas to form magnesium oxide solid in a 1-to-1 ratio. And since we have 2 oxygens, we need to double our magnesium oxide and thus double our magnesium. So this is an example of a synthesis reaction. Up next is the inverse of a synthesis reaction, which is called a decomposition reaction. So this is where we have some kind of compound that is falling apart into its respective components, decomposition. We are being decomposed. I don't know how to, rephrase that. So again, like I said, this is the exact inverse of our synthesis. So this is where we have some kind of compound that is now breaking up into its respective component species. So for example, if you take sodium bicarbonate and add a little bit of heat, you create CO2 gas, H2O, and what is the other product here? Let's go check our other notes. We did this the other day. Wednesday. Sodium carbonate, that makes sense. Na2, CO3 solid. All right, this is not balanced, so let's go ahead and balance it. I have 2 sodiums here, so I'm going to have to double the sodium bicarbonate. In doing so, I have doubled my CO2. Sorry, it's double my carbon, and then I have 2 carbons. I now have 2 hydrogens, and then 2 times 3 is 6. So 1, 2, 3, 4, 5, 6. Now I'm balanced. So decomposition, something splitting into its respective components. Okay, up next we have what's called single displacement reactions. You might hear this referred to as single replacement reactions. So to displace something, like displace water when you get into the bathtub, displace people, is to move them from their original habitat or placement, right? So single displacement is kicking something else out. I like to refer to this as the heartbreak reaction, where we have, let's say, component AB coming together with species C, If we're going to look at a single displacement, then we are going to look at one thing displacing one other thing. So here, this would result in B being displaced by C to form products A, C, and B. We say that B displaced C. So I call this the heartbreak reaction because you can think about it as you break up with your partner and they move on to somebody else. Or if you want to be the heartbreaker, you move on to somebody else and they're left alone. Okay, up next, something a little bit more complex. This is what's known as double displacement reactions. So in a single displacement reaction, we had one thing that was displacing one other thing. In a double displacement reaction, we're going to have two species that are displaced. So this is like compound AB reacting with compound CD, where we would have a displacement between B and D. So we would say that B and D displace one another. So I think about this one as like maybe the happy ending, right? This is where, yes, you might break up with your respective partner, but you both find love in the end. You both find new partners, you pair up. So AD would come together with CB, where I'm just retaining things written first, followed by new swapped things written second. That is our double displacement reaction. And lastly, our fifth main type of reaction is a combustion reaction. Where combustion has a very particular definition. So this is some kind of carbon-containing species, almost always a hydrocarbon reacting in the presence of oxygen gas. Typically, that is present in excess to form carbon dioxide gas and H2O gas or water vapor. And this also generates a lot of heat, which is why we like to use it as human beings. So we saw this earlier today when we were looking at the combustion of methane. So I believe we had to double our, well, let's go look. Yeah, double our oxygen and double our waters. So double oxygen, double water. So because we had a hydrocarbon plus oxygen forming always CO2 and H2O, that is how we know that this is a combustion, where these are our combustion products. So any chemical reaction you encounter is likely going to be one of these main 5 types. And if it's not just one of these 5 types, then it's probably going to be a bunch of them in series. So let's wrap up our video by saying that reactions can be one or any combination of these reaction types. And I shouldn't say any combo, I should say some combo, because it's unlikely that we see a combustion followed by some kind of, I don't know, double displacement, but we might see some kind of combustion followed by a thermal decomposition or something. But in general, we are going to look at reactions that might be one of these or a couple of these. And where we're headed next is we're going to look at reactions that occur in solution, or aqueous reactions. And all aqueous reactions, or all reactions that occur in solution that we're going to encounter in Chem 210, are going to be some type of double displacement or single displacement, and perhaps even involved some kind of decomposition. So coming up on Wednesday, we'll start looking at our different types of aqueous reactions, and then we'll continue on from there. So we'll see you tomorrow.